In 1999, Japanese manga artist Ryo Tatsuki, in a book, The Future I Saw, predicted that on 5th of July 2025, southern Japan will be hit by a massive tsunami. Today, a tsunami has occurred across the Japanese coastline. So while we can say that the prediction was not exactly accurate to the exact date, but at least the month and the year is where Ryo Tatsuki stands vindicated. Hello and welcome to Unacademy, one-stop destination for civil services aspirants. In this session, we are going to discuss about the massive earthquake, which is one of the largest in terms of its magnitude to have hit the eastern region of Russia in over the past 7 decades. That has triggered massive tsunami warnings across the region of Pacific, from northern portion of North America to the southern hemisphere, even in the region around the Chilean coastline and even across the New Zealand coastline. Now, why is it that this earthquake has occurred, which is said to be one of the 10 most massive earthquakes recorded in history? Now, what is the genesis of this earthquake? Where has it occurred? What is the type of this earthquake? What you should know for the examination, and how did it trigger a tsunami? But before anything else, the earthquake that we are talking about had a magnitude around 8.8 on the Richter scale, which tells you about the huge amount of energy which was released at the point of convergence. But before anything else, where did this earthquake occur? And what was the epicenter and the chief characteristics? Starting with the location. So here you can see this is the region around which the earthquake has occurred. That is the epicenter of the earthquake. Now this is across the far east of Russia, around the region of the Kamchatka Peninsula. Now you have to keep in mind that the Kamchatka Peninsula has been one of the hotspots of earthquakes as well as volcanic activities, in the sense there have been numerous different volcanic activities happening in this region. Now there are two plates in question which are involved. One is the region of the Pacific plate and the other is the Okhotsk plate. We will take a look into both of them. But here you can see this is the entire zone of convergence. And the earthquake which originated and germinated from here has triggered a tsunami which can reach up to the region of Hawaii. And as we speak, it has already hit the regions around Alaska and is progressing across the western coast of the US. And multiple waves are expected to hit this coastline in the next few hours. Now, very briefly about the chief characteristics of the earthquake. Now, basically, the earthquake took place across the region of the Kuril Islands, and that is the Kuril-Kamchatka Trench. Now, trench, the deeper portions of the oceans where there is convergence which is happening. So, this is the Kuril-Kamchatka Trench, across which the Pacific plate is undergoing subsidence, and there is a large-scale subduction of the Pacific plate which is happening. Now, here you will observe that the Pacific plate dives beneath the Okhotsk plate. Okhotsk plate is a minor plate which has nowadays started behaving independently. Now it is classified as a shallow reverse fault earthquake. What is that? We will also take a look into that. And it is a megathrust earthquake. What is a megathrust earthquake? It is a massive earthquake, oftentimes with a magnitude of 8 and 8.5 above. So obviously one of the most giant earthquakes which occur, and mostly in the regions of the subduction zone, where you basically have the zones of convergences. Oftentimes these megatherm earthquakes, or rather the megathrust earthquakes, now they oftentimes end up triggering a tsunami. We have seen that in the case of the Indian Ocean as well. Now, having said that, the epicenter is 120 to around 126 kilometers to the east of the region of the Kamchatka Peninsula, and at a very shallow depth, that is 19 kilometers from the surface. So very, very close to the surface. So that is why the term shallow is used here. Now the plates which are in question, we will discuss about that. But before that, in order to understand the basics of the subjects and in order to prepare for the civil services examination, you need a good grip of not only the static portion but also current affairs. For that, we bring for you a comprehensive guided program at a lucrative cost of 19,999 with up to 12 months of extension. And this lucrative program exists up till around 1st of August only. So avail this opportunity, use the code IAS English and avail maximum discount. With the help of this course, you will be able to finish the lectures within the syllabus, what is required, nothing more, nothing less, mentorship, guidance regarding doubt solving in the live classes, guidance regarding answer writing practices, PYQ discussion, and a comprehensive preparation strategy thereby. Now, having said that, we were talking about the megathrust earthquakes. Now, when you take a look at the examples of megathrust earthquakes, one of the most massive earthquakes recorded in history was in 1960 when it rocked the region of Chile, the western portion of Chile, because that is also a zone of convergence and a zone of oceanic plate subduction. And that was having a magnitude of 9.5. That also triggered a tsunami. And as you can see, it is one of the largest earthquake ever recorded. Then thereby, 2004, the December 26th earthquake in Indian Ocean. Now, that also had a magnitude of 9.1 to around 9.3, and the tsunami which was created ended up claiming lives of more than 200,000 people. And the last time that it occurred was in 2011 across the region of Japan. So these are your megathrust earthquakes. Mega as in very, very large. Now, why has it occurred this time? So, this is the region of the convergence zone, as you can see. This is your Okhotsk plate. And Okhotsk plate is considered to be one of the remnants of the North American plate. The North American plate would extend even south. But then, owing to plate movements, there was a breakage and you had a separation of the Okhotsk plate. Now, the Pacific plate being the heavier one out of them, the Pacific plate is undergoing subduction here. And there's a zone of convergence where the Pacific plate keeps on going lower. And as a consequence of that, so here basically imagine this is your Okhotsk plate, which is lighter in terms of its density, and the Pacific plate is actually going down. Now, in this region, there's a zone of deformation which is created. Now, this is what forms what we have already taken a look at as the Kuril-Kamchatka trench. That is the region of your trench. Okay. And this is where this subduction or the subsidence of the plate in a way. Now, that is creating a kind of release of energy. Why? Because we have to understand that when the movement of the plate happens, it is not smooth. We are talking about many kilometers of rocks undergoing that subduction. So, as a consequence of that, there is a rough movement and there are a lot of frictional forces offered by the rocks. As a result of the frictional force, the rock movement ends up stagnating for a bit. And after some time, when eventually the force of movement is very high, this force of resistance is overcome and the rocks end up suddenly moving. As a consequence, energy is released, which we record on the seismographs. Now here, in this particular area to the east of Kamchatka Peninsula, prior to the occurrence of this mega thrust earthquake, you had 4 shocks. That is, the seismic activities recorded prior to the main earthquake. The 4 shocks had a magnitude around 7, which tells you that there was a huge energy which was building up. And even after this earthquake has occurred, aftershocks of a magnitude around 6 and 6.2 have been observed in this region within a couple of hours today itself. So again, that means the rocks are trying to gain stability and there can be more such aftershocks in the next few days. So this is about the Okhotsk plate, which is a minor plate in question. So it is located on the western side, or rather, when you talk about the region of Asia, so it will be located across the eastern side of Asia and western side of the region of Pacific. So it will be located across the region of eastern side of Asia. Okay, primarily under the Okhotsk Sea, but also the Kamchatka Peninsula, the region of the Sakhalin Islands, very rich in oil reserves, and northern half of Japan. That is the overall encapsulation of the Okhotsk Plate. It was considered part of the North American plate, but over a period of time, owing to transform movements to the north, it is showing a kind of an independent nature of movement on its own. Now comes another pertinent question, and that is, what do we mean by the shallow reverse fault earthquakes? Shallow means something which is of a lower depth. So we have seen that the epicenter is only 19 kilometers from the surface. So hence the term shallow is used. But what do we mean by the reverse fault earthquake here, and how do they occur? So reverse fault is basically a large crack which is created when you have compressional action. So basically you can think about it that, and here you have to be able to visualize slightly. So think about it. So let's suppose the Okhotsk Plate that we have discussed. Now this is the width of the Okhotsk Plate. Now here you have the subduction of the Pacific Plate which is happening. This is the region of the trench. Now above it, obviously you have water, that is the ocean, the Okhotsk Sea and the North Pacific. Now think about it, as this Pacific Plate, it is undergoing subduction, right? And this is the region of Okhotsk Plate. So as it is undergoing subduction, we have discussed that the movement will not be smooth. But focus upon what will happen to the region of Okhotsk Plate. Now the Okhotsk Plate, which is on top, and the Pacific Plate is undergoing subduction. Now Okhotsk Plate will also behave differently at different levels. Let me simplify it. The lower region of this Okhotsk Plate will try to go along with the Pacific Plate. The Pacific Plate will try to drag it along with that. But the upper portion of the Okhotsk Plate will not face that deformation to such an extent. So there is a kind of a decoupling of the rocks within various different layers itself. Right? Imagine I have this plastic piece in my hand. Now if I try to fold it or if I try to break it, will that be broken in a perfectly symmetrical line? Obviously not. The lower portion will break differently, the upper portion will tend to throw itself up. The upper portion will try to break independently, right? So as a consequence of that, when the plate breaks here, this upper portion experiences an upward elastic motion, that is owing to compression. Always keep in mind that there is a convergence and a compression which is happening. So as it is being compressed, the lower portions are getting deformed, but the upper portion simply gives way. And when the upper portion gives way here and it decouples from the lower portion of this Okhotsk Plate, that disturbs the water underneath, and that creates giant waves. And those giant waves we refer to as the tsunamis. With the help of this animation, you will be able to understand that how these tsunamis are generated. As you can see in this animation clearly, that there is a disturbance which happens at the bed of the ocean floor. Now in that region, due to the disturbance at the zone of convergence, there is massive energy which is released, and that energy disturbs the water and the waves are generated, and as you can see, the waves will travel in all directions. That is why, despite the fact that the earthquake has occurred in the northeastern, or rather the northwestern part of the Pacific Ocean, the tsunami warnings have been generated across the entirety of the coastal areas of the Pacific Ocean. But how are these tsunami warnings generated? What is the entire process behind it? So when we talk about tsunami warnings, there is a complex set of systems interconnected together which give you the warning of a tsunami prior to when it hits the coastline. So as you can see in this particular image, there are certain buoys, right? Buoys as in certain floating devices which are basically hooked onto the ocean floor. And as there is an earthquake which is triggered oftentimes, now as a consequence when the waves are generated, these floating devices also move. Sudden movement of these devices triggers us an alarm and a communication signal, and that is then caught by the communication satellites. These satellites then they distribute, and in a way they alert the ground-based stations, and that is when the tsunami warnings are issued. The tsunamis have been recorded in the region of Russia, Japan, and even across the US coastline, and Hawaii is bracing for that impact. So that is about the megathrust earthquake, what is a shallow reverse fault earthquake, and why it has triggered a tsunami. Very briefly, a quick recap of what we have discussed till now. So basically, we have discussed what is this earthquake, why has this earthquake occurred in the region, which are the plates which are involved. It is the Pacific plate which is undergoing subduction underneath the Okhotsk plate. What is that Okhotsk plate? Where is it present? And also, why that reverse fault earthquake, that terminology is used. We have seen how that elastic limit of the rocks, when they give way, then there's a kind of a rebound which generates a tsunami, and with the help of the animation, we have also taken a look at the tsunami. I hope that this has added to your existing knowledge set, and if you have liked the content, put that in the comment section, and don't forget to click on the like, share and the subscribe button. Till we meet again, take care, goodbye, thank you.